Okay, I think I'm going to have to ask him to go first. When you touched it, you moved the cable and now it's gone. I'm not kidding. Yeah.
It doesn't work?
No, it's not showing up on the screen. Yeah, let's try that, but I'm not very confident. That's why I didn't want to touch it. These kind of cables are really buggy.
Quick switch.
Yeah. You have internet. Can I play YouTube videos? Okay, I'll try. I may. Yeah.
You need YouTube videos.
Don't worry about it. I'll click if it works. If it doesn't.
Good.
Display. Yeah. Monitor. I think monitor is the one.
Yeah, that versus
Now? Yeah. Space?
Okay, good. So this is a reactive session, and the first talk would be about bridging a GUI, guys, by Ivan Paris.
Thank you. Can you all hear me? Yeah? So this is work that I've been doing with Henrik Nielsen, and apart from doing my PhD at the University of Nottingham, I have a company, and I've been putting this in production as well. So there's a very pragmatic nature to what I'm going to present here. The context is applications with user interfaces and Haskell. I'm not so concerned about creating the actual user interfaces in Haskell. I'm more concerned about creating programs with user interfaces and creating all the backend in Haskell and connecting it to what's shown on the screen. Usually when you want to write a program with a user interface, you opt for a GUI toolkit. And examples of this are Qt or GTK or WX. Android and iOS have their own GUI toolkits. They simplify a lot of the work, so it's what most people end up doing. But their state, they have a sense of state. They have control of their own, and they're event-oriented. The problem if you try to write Haskell software using the APIs available for these toolkits is that it's going to be imperative. It's going to be low level. It's going to be hard to understand. Like this. Apart from these spaces, I mean, I could space it out a little better, but still, there are functional features. There's function composition. There's for-m, map-m. It was somewhere else. But still, it's mostly imperative. It's difficult to follow what's going on. GUI toolkits work by installing event handlers that execute operations when the users interact with the user interface in certain ways. So you're essentially breaking your program into little chunks like this and installing them all over the place. And it's really hard to understand what's going on. So at some point, you ditch all of the code that you wrote in an imperative style, and you hear about this wonderful thing called FRP. So you start trying to apply FRP. And if you're talking about GUIs, actually FRP is about time. It's about abstracting time away. You have delays, you can slow time down sometimes depending on the implementation. But GUI toolkits are event-based. Time in a GUI toolkit, in the FRP analogy, would be discrete and unit pace. I mean, every step would be just 1 unit more than the last one. GUI toolkits don't keep a clock for you. So it does get in the way a little bit, and depending on the implementation that you use, and especially in Haskell, because there's no easy way to import to modules in a circular way, what you end up with is that most of the code is in the same place of your application. Sometimes in the same module, sometimes if you're using something like Yampa, in the same arrow block. An example would be something like this. Imagine that you want to program a Journal, which is a PDF annotation software, and you have the page of the PDF that you want to annotate. And here, you can see that you're actually seeing the page number that you're editing. And you can modify that and scroll down the page by just interacting with this widget. But you can also do it over there using the scroll bar. You can also do it up there using those buttons that are just highlighted. So you have different ways to interact with something that lives in your model, which is the current page number. If you use something like FRP to program this, what you have in your model is a signal that defines the page number. And that signal is defined by its dependencies on other signals, including whether the user clicks over there, whether the user touches here, it modifies this, whether the user scrolls down the bar. So there's many widgets and many other signals that have to be within scope when you define the signal of the current page number. And the other way around, because this widget is bidirectional, it has to show the page number, not only change it. When you define the signal that shows this text, the page number in the model has to be also in scope. So they have to be in scope of one another. They have to be defined in the same module or sometimes same arrow block. So these programs don't scale so well, actually. Eventually, you just ditch it, and you try to go back to what you really wanted, which is to write user interfaces in a way that's simple, it's easy to understand, and you want to be able to use different backends. You don't need to be able to use Painted or anything like that, animation. You just want business applications. There's a common topic to all the things that happen in GUI programming and also other external systems is that you want to observe what's going on. You want to see the values of attributes. You want to be able to change them. And you want to know when they change. You want to be notified when they change. So it's, again, event-driven, state-based. When you don't know the answer, you go back to your master for wisdom. And in my case, my second master is Graham Hatton. So we have the Graham Hatton bingo of the things that Graham Hatton usually says. You ask Graham, and he says, just do the obvious thing. I'm glad that the resolution is so slow in case they're recording, because then it won't show up and he won't kick me. Just do the obvious thing. What's the obvious thing? Well, we talked about types. We talked about reading and writing. We talked about change notification. Let's just do that. So reactive values are typed read-write values, and we can get notifications when they change. Under the hood, they use set, get, and notify in the obvious reactive way, but we're not going to use it. We're just going to move one level up and try to connect them in a more declarative way. So, for instance, this is one example of what we find in user interfaces. This button, for instance, has one attribute, which is whether it's enabled or disabled. And in this example, we might want to disable that button if there's no project name, if the project name is empty. Events are actually read-only reactive values that carry a unit value, a value of unit type. And when we have events that reflect changes to existing attributes, like in the case of the text attribute and the key presses, we can create one reactive value that uses both of them, so that when we get key presses, we get notified, and when we read from that reactive value, we are actually reading the text, which is what must have changed. We can also modify them. So we can take a reactive value and wrap it around a function that will perform a transformation in the read direction or in the right direction. So for instance, if we lift reverse on a text box text, which might be a readable, writable reactive value of type string, we get something from which we can also read a string. Note, though, that we're lifting only in one direction. So now we can no longer change, because we're modifying the type. In this case, it's the same type, but it doesn't really have to be. If you want to keep being able to write, you can lift both directions of the transformation. And so we have, for instance, reverse over there. Nobody checks that you're actually lifting an isomorphism. You have to do that on your own. But still, if it settles at some point, if you have circular dependencies, if it settles, then it's okay. This is just a very brief view of the API. There's a lot more on the website. You can take a pure Haskell value and create a reactive value around it. And you can do that in two ways. In the obvious way, so that whenever you change any part of that value, anything that depends on it will get a notification. Or in a more sophisticated way, and what you do is you extend your pure value with a notion of events or things that change within the value, so that you can only trigger notifications if the things that depend on specific parts of your model actually need to be notified. Let's say, for instance, that you have a model with two fields, a name and a surname. You may want to know when only the name changed, so that you don't refresh the surname on the screen if the surname has not really changed. You can lift arbitrary actions, monadic actions. This signature that I show here is actually parameterized over a monad as well. So you can use any other monad. It doesn't always have to be the AO monad, although it is the most common, especially in GTK. You can add predicates to make sure that things don't propagate if certain predicates don't get fulfilled. You can use lenses to look within a reactive value. And you can make a reactive value passive so that it doesn't really notify you of changes. And that's very useful for something called governance, in which, for instance, a button is governing a text box. This is a reactive value that will tell us when, that will give us the value of the text box, but only when we click on the button. So even if that value changes on the text box, it's not going to send notifications. It's only going to do that when the button is clicked. And that works by making the text box passive and then lifting the constant function on the pair of the two. So far, we can take a widget, we can take an attribute or a property of a widget, we can turn it into a reactive value. How do we connect it to other widgets, to our model, to external systems? And what is used are reactive rules, and these just install the proper event handlers so that things are kept in sync. So one obvious case would be this. Let's say, for instance, that we have the, can you see the mouse here? Yeah. If we have the enabled attribute of this button, we can use this function from the library to get that attribute turned into a reactive value and be able to change it and modify it and know when it changed. And from this, I don't know if you can, maybe I should zoom in or something. Oh. Sorry about that. Okay. Now sorry, I was trying to zoom in, but I don't know the layout of this keyboard. So for instance, in this case, we have a project name text box, which is this one, and when it's empty, we don't want this button to be enabled. So what we do is we lift a function that calculates the length of the text and checks whether it's greater than 0. And that is a Boolean readable reactive value that is assigned to this other reactive value. So whenever this one changes, this one gets updated. The effect that this has on applications is that your controller, in model view controller, your controller becomes a bunch of rules, synchronization rules. You can still do all the things that you would classically do in a controller. You can send things over the network and all of that. But keeping things in sync, which is something that you always do in this kind of applications. You have a view that is actually a projection on the screen, a bidirectional projection on the screen of the model, is only done using synchronization rules. The effect that that also has is that there's a lot of behavior that is replicated across programs that has nothing to do with the problem that you're trying to solve. For instance, showing the title of the currently open project on the title bar. So showing the name of the currently open project on the title bar of a window. That's something that every program does, but it has nothing to do with the problem that you're trying to solve. And GUI programs are full of those things. And they take so much code. And by abstracting over views with certain reactive values, over models with certain reactive values, you can move these synchronization rules away into separate libraries. That's what we call choreographies. And you can include threads in those choreographies. You can include your own models, your own views, pop-up message boxes, or whatever you want. The difference with FRP is that there's no time. In FRP, signals are defined by their connections to other signals. And here we're defining values that change over time in one place and then connecting them in another place. Widgets are given. Some FRP or FP implementations that try to address the widget problem actually create a GUI toolkit themselves. Here we assume that it already exists and we're trying to connect to it. And I think it complements FRP. It doesn't really overlap in that sense. I think there's a place for both, even within the same application. Okay, so I said that this was being used, and there's a few applications that I've written this way. This has been going on for 5 years now. And this is a posture monitor that uses the webcam to look at you. You calibrate it, you sit correctly calibrated, and if you start slouching or doing something strange with your back, it will pop up a message and tell you that you should sit correctly. This is on GitHub, by the way. There's a few other examples. I don't know if I can. Okay. Maybe in just a second I'll open a browser and show you around. There's a lot of code here. There's something like 10 or 12 libraries that allow you to connect to GTK, WX, Qt, different Wiimote as well. There's examples of how to connect to other hardware devices, how to connect to Yampa and use FRP in a pushed base. So essentially, because reactive values are pushed based and Yampa is pull based, what you get if you connect both is that you only execute the actual simulation if something has changed, but it's actually still pull based. And then there's this project that there's a video online. I don't know if I can show you, but there's a video online. This is a graphic adventure development environment written in Haskell, and it uses reactive programming. The combined size of the code base of the Gale development environment is something like 25,000 lines. So this is definitely non-trivial. There's also a PDF renamer that I wrote for a company, for instance, that did explored a bunch of files and did OCR and then renamed all the files. And this was used by people who don't know anything about computers. And they really needed a GUI toolkit to do this. So I complained at some point about the coverage that some FRP libraries have of existing bindings. With this library, 80% of GTK is covered. When I say 80%, I mean 80% of, I think I had it here. Yeah, GTK2 exports over 5,000 symbols. Of those 5,000, 2,600 are event handler installers, signals, attributes, getters, setters. There's a script in the library that browses all of the symbols defined and tries to pattern match on the signatures of different event handler installers and signals, and does the right thing for most of them. So 2,100, more or less, are covered by the script. There's, as I said, examples for, let me see. Yeah, WX and Qt. I have this running on my Android phone using the Android backend of GAC. And it talks to Java using GNI. So the user interface is created in Java in the normal way that you would do on Android. And it talks to Haskell, and Haskell does all the event passing, and you can write your application in this way. This is actually particularly important on Android because there's a lot that's going on. It's not just showing the user interface. Android, for instance, selects the right user interface from the right XML file depending on the size of your screen, whether you rotate the screen, the language, things that may change even during the execution. Thanks to Hamish and Loite, I wrote yesterday a very small example of how to connect this to HTML DOM and run it on a browser using the JavaScript backend of GAC. And it took us roughly 30 minutes or something like that. Yeah. So from scratch, without ever having used GAC.js. Well, he's the expert, so yeah, something like 30 minutes we had it running on the screen. Files can be seen as reactive values, and iNotify is used to detect changes to files, network sockets as well. And as I said, there's a connection to Yampa, so there's ways to connect it to FRP implementations. There's a lot to be done, and in particular, I know that in this community, what things mean over time and a precise meaning is important. So even though you can use this already, I think it would be important to give a precise definition of how things change over time. The problem with GUI toolkits, especially things like GTK, is that they're loosely defined. And even if, for instance, basic things that you would get in the lens laws, such as that if you set something and you get immediately afterwards, you will get what you just said. They don't happen in GTK. You might set a range that is out of, a value that is out of range. Something might happen in between. So, but still, it would be nice to know that if you fulfill the preconditions during runtime, that things will behave normally. And most reactive values do behave in this way. You can actually, as I think I mentioned it before, you can do equational reasoning. So if you lift things and you have a synchronization rule, it doesn't matter whether you lift on one side or the other. If you lift on both sides, then you can actually combine those. If you lift several times, if you create a reactive value, you lift and then you lift again, you can actually lift the composition. So they behave in the way that you would normally expect. And yeah, so that's pretty much it. This gives a really uniform way of seeing models, of seeing views, of seeing external systems, Wii modes, network, all of these things. And it's compositional, it's declarative, which is what we were looking for. And it's actually quite modular because the rules involving the same reactive values can be defined separately. You can define a set of rules that implement a specific connection in one place and another set of rules in another module. And you can even comment it at some point during execution. And if you want to debug a specific feature. So that's it. That's pretty much it. I have examples online, but I cannot show you on this computer. So if anyone is interested, I have my laptop, and I can show you the code. I can show you the GitHub library, whatever. Any questions?
All right, so in your motivation, you said that FRP is not modular because things have to be in scope, right? And,
yeah.
So this holds for arrowized FRP, but if you have first-class behaviors, this consideration goes away. Supposing you have first-class behaviors, does this still complement FRP, or is it then, what is going on then?
Why do you think it goes away?
It goes away because if you have if you have an arrow, it says it goes from A to B. If you have first-class behaviors, you only state the B. The A is not present in the type anymore, so it doesn't have to be in scope, basically.
Sorry. I didn't get that.
So it's subtle, but in arrowized FRP, you cannot talk about things that change over time without stating what they depend on, right?
Yeah.
And if you have first-class behaviors, this is possible.
Yeah, but when you define it, you still have to have it in scope. When you say, this is my signal, is defined in terms of all of these other signals. Those signals have to be within scope. Do you see it? You actually have to have them defined somewhere, either imported from some module or defined in the same module. And you don't have circular imports between modules.
I think we can probably take it. I also got the same portion, but I don't think without showing code we...
Okay, yeah, fair enough.
So you haven't shown us any code, so it's hard to get a sense for what this is like. One of the things I wanted to ask there was about, you described how you could sort of establish a connection that some button governs some widget, and you talked about having compositional rules. So I imagine there's some way in which you could say this, now this button should be governed by this thing. I'm wondering whether there's a way to, how can you withdraw the rule,
At the
as it
present
were?
time,
Can you sort of change all these connections once you've established them?
At the present time, I'm not addressing that.
Oh, okay.
Simply because 80% of, or 90% of the applications that I had to write were actually just a projection of the model. The model was the one doing, using just the visual properties of different widgets, you can show things and hide things, and you get some sort of dynamism. So you don't really need always to change the behavior of the application in that way. I understand that there's a
I see.
place
So
for
if
that.
you might want to say, if you press a button, then the behavior of your display changes a bit, and that would be difficult as now. Is that right?
I'm not sure it would be difficult, but it definitely has not been designed to
Okay.
do that right now. It's in future work.
Very short? Oh,
It's-
okay.
Just one thing about the code. The problem, Simon, about the code. The problem was that I had to use somebody else's laptop, but I do have it here. I'm sure you have code. Yeah.